how to use GDC to solve quadratic equation. Right, we choose add calculator, and then from there we choose menu, and number 3 algebra, and we have numerical solve when we are looking for a variable, and solve linear equations when we have two equations or more, and polynomial too. We are looking for, if we are using quadratic, this is what we're going to choose. Find roots, and then degree is 2, the highest power is 2, roots real, okay. And these are the value. A2 here is coefficient at x squared, A1 coefficient at x, and A0 here the coefficient at x power 0. Okay, A2 should be 4, and this should be positive 40, and this will be 1 minus 1501. That should be negative 1500. We need to solve it and equate it to 0. So we get negative 1500. Let's see what we get. So this is how we're going to come out. Polyroots, and we have comma x. It will be generated there, and equal. So we have negative 25, the first value, and 15 as our x, or w here should be a number of squares wide, and numbers can't be negative, so we reject negative 25. The answer should be 15. Alright, so next, how if we're going to use graph to solve it. Okay, let's see how we can do. Tab, add page, okay, not that, control, add page, so we get add graph. Okay, so this is a graph, and what graph we're going to plot here? First, we're going to plot 4w squared, so we're going to use x for x squared, and plus 40x, and then we get a plus 1. Okay, so we don't have to solve it with 1501 because we're going to plot that in a different graph. Okay, so now we put it. Okay, so if you see here, you can't see the whole graph. There are a few ways of doing this. We can change the range to window setting, or we can just zoom out, so it will be wider. Okay, let's see how it goes. Well, this is what we got. It's too thin. Okay, so we can always change here. So we see it's not up to negative 173. We can change that, and this is like a negative 100 something. Alright, so let's see what we can do. We change from window setting, right? Minimum, maybe we can put negative 100. Not sure, maybe just negative 50. X maximum, maybe 50. Let's try this out. And Y minimum, maybe, yeah, let's try a negative 120. Okay, or Y maximum, we just put 50. Let's see how it look like. Alright, slightly better. So we don't need up to 50, we know that now. So we can change from window zoom, window setting. So we don't need that, negative 20 maybe enough. Or here, then we make it as 20. Okay. Okay, so now it's look better. Alright, so we have another variable there, 1501. So that will be another graph, another line. So go to menu. So we put graph entry. So we put another function. So that will be 1501. That will be a straight line. Okay, let's see where it goes. As we have a maximum 50 here, maybe now we need to change it. And the window setting. The Y maximum shouldn't be 50 because that 1005 or 1, so maybe 1520. Let's see. Alright, so now we can see that. Okay, so we can also zoom out if we want to. Okay, so let's see if we zoom. Aha, this one is better. So where can we find the solution for it? The solution between this, the quadratic graph, and the 1500 one value is where it crosses, where it intersects. Here on the menu, we go to Analyze Graph, Intersection. So we click here, lower bound, and then we trace here. And it's also mentioned that intersection, negative 251501, we get the coordinate where we can maybe move it. So that is a coordinate where it crosses. We can also move this label. Okay, this is the graph, the blue graph functions, yeah. And we need one more here. So again, menu, analyze graph, intersection. Get here and then up to here. Get nicely coordinate 15, 1001, 1501. So again, the x or the w in this story is the squares y. So that is how we get 15 as our value. Okay, the point of intersection.